ice absorbs heat, measured in joules, its temperature will increase until it reaches 0 degrees Celsius. At this temperature, it undergoes the phase change of melting. Now, as in all phase changes, the temperature remains the same until the phase change is completed. When the ice has completely melted and heat is still being applied, the temperature of the water will increase as the water absorbs heat energy. So as water is melting, it is absorbing heat energy. After it has melted, it will continue to absorb heat energy. At 100 degrees Celsius, at sea level, the water has reached its boiling points and begins to boil. It will stay at this temperature during this phase change while continuing to absorb heat. During the phase changes of condensation and freezing, heat is released. It seems strange that as water freezes, it releases heat. But it is exactly what happens. In fact, within a hurricane, a tremendous amount of heat is released when water vapor condenses. This is a major source of energy for the hurricane. The chart. For ice to melt from a solid to a liquid, it must absorb heat. The chart shows that 334 joules are absorbed or gained for every gram of ice that melts. For water to freeze, or going from a liquid to solid, it must release or lose 334 joules for every gram of water that freezes. Notice that in these two phase changes, the number of joules are the same, but the difference is whether the energy is being absorbed or being released. Both of these phase changes occur at 0 degrees Celsius, and the temperature remains the same while the phase change is occurring. In vaporization, or boiling or evaporation, a liquid changes into a gas. For vaporization of 1 gram of water, the chart shows that 2,260 joules are absorbed. When condensation occurs, which is a gas to a liquid, each gram of water vapor releases 2,260 joules as it changes back into liquid water. Both of the phase changes occur at 100 degrees Celsius, and the temperature remains the same while the phase change is occurring. The density value of water is 1 gram per milliliter. As shown on the chart, this occurs at 3.98 degrees Celsius, which can be rounded up to 4 degrees Celsius. When water warms from this temperature, its density slightly decreases. This is why warm water rises, being displaced upward by the sinking, cooler, denser water. Additional information. Any substance that has a density less than 1 gram per cubic centimeters will float in water, while a substance with a density more than 1 gram per cubic centimeter will sink when placed in water. Ice floats in water since its density is very close to 0.9 grams per cubic centimeters, which is less than 1 gram per cubic centimeter. Question number 1. Which phase change requires water to gain 2,260 joules per gram? So our clues here, phase change, so we know we're talking about properties of water, and gain 2,260 joules per gram. So if you look at the chart on the first page of your reference table, you will see that you have 4 choices. You have melting, freezing, vaporization, and condensing. And you need to pick the one which is gaining or absorbing 2,260 joules per gram. Question number 2. During which phase change of water is the most energy released into the environment. So our clues here is phase change, so we know that we're looking at properties of water, and it says released and most energy. So we're looking for the largest number which is released into the environment. So again, taking a look at your reference table, you have 4 choices. Look for the largest number that is being released. Question number 3. How many joules are required to evaporate 1 gram of boiling water? So you need to take a look at your chart. It's asking you how many joules are required to evaporate 1 gram of boiling water. It'll be a fairly simple and straightforward question. Occasionally they will ask you more than 1 gram, in which case you would have to multiply that number, which is given on the table, by whatever number of grams they give you in the question. Question number 4. Which statement best explains why water in a glass becomes colder when ice cubes are added? So the important thing to remember with this statement is something that wasn't in the reading before, and that is the idea of sources and sinks. Remember that energy always flows from sources to sinks. And so what you need to decide when looking at this is whether or not the water in the glass is the source of energy or is a sink of energy. Remember that when ice is added to water, the ice begins to melt. So when you are melting, are you absorbing heat or are you releasing heat? That is another way to think about it as you are looking at the chart on the first page of the reference table. Question number 5. What is the total number of joules required to melt 100 grams of ice at 0 degrees to liquid water at 0 degrees? So again, we're talking about 0 degrees to 0 degrees. That's no temperature change. That means that we're talking about a phase change. Our phase change is melting, and we are melting 100 grams. Now remember, before on one of the other questions I had stated that sometimes they will give you the same kind of question, but they will give you a mass. So in this instance, you need to multiply the energy that goes into melting the ice by 100 grams in order to find out what that total number of joules are that are required. Question number 6. The cartoon below presents a humorous look at science, and unfortunately they don't really use a lot of comic strips anymore on the Regents exam, and this happens to be one of my absolute favorite comic strips, Calvin and Hobbes. Calvin says to his father, "Why does ice float?" His father states, "Because it's cold. Ice wants to get warm, so it goes to the top of liquids in order to be nearer to the sun." Calvin, "Is that true?" His father, "Look it up and find out." Calvin, "I should have just looked stuff up in the first place." And his father states, "You can learn a lot talking to me." So the correct explanation of why ice floats is that compared to liquid water, solid ice is. And so you have to remember one of the statements that was made at the very end of the reading at the beginning of this review packet about ice. That wraps up this review, properties of water and of the specific heats of common materials. Make sure that you are prepared on Thursday. We're going to go over the answers, and then on Friday we'll have a quiz. So if you have any questions, be ready on Thursday to ask the questions for the quiz on Friday.